we need to find out the value of I. Here means we have to integrate over the contour which is given where mod z equals to 2. So within the contour given by mod z equals to 2, there is only one pole, that is z plus 1. Means we need to calculate the residue at that point, that is here I is nothing but summation over residue at z plus 1, that is e power minus 1 divided by 2, which is plus 0 at z equals to minus 3. Hence it is going to be 1 by 2a, hence option A is correct.
If A is an orthogonal matrix, then we have to find the value of determinant of A. So it is given that A is orthogonal. Orthogonal is nothing but A into A transpose or A transpose into A will be always equals to I. Now if I apply determinant to the above equation, A into A transpose determinant equals to I. So we can write this as A transpose is equals to 1. Now also we know that determinant of A transpose and determinant of A are equal. So we can write this as determinant of A square is equals to 1. So the determinant of A will be plus or minus 1. That is option D. If A die is rolled and is saying that A denotes the event of obtaining a number less than or equal to 5, whereas B is the event of obtaining a number that is odd number. Then we have to check which of the given options is correct. Now A is an event of obtaining number less than or equals to 5. So there are totally 5 chances. It could be 1, 2, 3, 4, 5 out of 6 chances. And B is an event of obtaining an odd number. Odd number can be 1, 3, 5. So there are 3 chances out of 6 chances. Next, let us see what will be the intersection part. That is A intersection B. A intersection will be again 1, 3 and 5. Now what will be the probability of intersection of A and B? We have 3 chances out of 6 chances, which will be 1 by 2. And what will be the probability of B happening of event B? There are 3 chances out of 6, which will be half. Now let us calculate the value of P of A by B. We know that P of A by B is nothing but P of A intersection B by P of B. Let us substitute these values. P of A by B is nothing but 1 by 2 by P of B is 1 by 2. So the value is 1. Hence option A. In this problem, we have to evaluate the integral 0 to 1 by 1 plus x squared dx by using Simpson's one-third rule, dividing into 6 equal parts. Now here n is given as 6 and the integral is 0 to 1 by 1 plus x squared dx, whereas A is 0 and B is 1. Let us calculate h. H is nothing but b minus a by n, which is 1 by 6. In order to calculate this integral by Simpson's rule, let us find the values. That means Simpson's variables. Let us take x and y. So x0, x1, x2, x3, x4, x5 and x6, so that the total intervals will be 6. Now x0 will be 0, x1 will be plus 1 by 6, that is 1 by 6, x2 will be 2 by 6, what is 1 by 3, x3 will be 3 by 6, that is 1 by 2. Now x4 will be 4 by 6, that is 2 by 3, x5 will be 5 by 6 and x6 will be 6 by 6, that is 1. Now let us substitute these values in the given function to evaluate y0, y1 and so on. So if I substitute x0 as 0, then y0 will be 0 and y1 will be 0.162. Similarly y2 is 0.3, y3 is 0.4, y4 will be 0.491, 461 and y5 will be 0.491 and y6 will be 0.5. Now 0 to 1 dx by 1 plus x square. Simpson's rule is nothing but h by 3 into first term plus last term, which is y0 plus y6 plus 4 times of the values in the even places, that is y1 plus y3 plus y5 plus 2 times the values in the odd places. So y2 plus y6. y2 plus y4 because we have taken y6 already. So let us substitute the values. H is 1 by 6 and by 3. So 1 by 18 and y0 plus y6 which is 0 plus 0.5 plus 4 into y1. y1 is 0.162 plus y3 plus y3. The value of y3 is 0.4. y5 is 0.491 plus 2 times of y2 plus y4 which is nothing but 0.3 plus 0.461. If we simplify, then the value will be 0.34634 which is option B.
Is the Z transform of the real and right-sided sequence x of n has two poles, and one of them is at z equals to e power z pi by 2, and there are two zeros at the horizon. If x of 1 equals to 1, then which one of the following is true? That is, here x of z can be written as so. From this one, if we simplify this one, we will get z square plus 1, that is kz square. From the given data, we know that x of z at z equals to 1 equals to 1. If we solve k by 2, that is k equals to 2. So from this one, 2z square by z square plus 1, we know that from the right sided sequence means it is that particular x of n is multiplied with u of n, whose ROC is mod z greater than 1. Hence, its ROC is mod z greater than 1, which is option D is correct. Suppose x of k is the 6-point discrete Fourier transform of x of n, and y of k equals to w6 4k x of k, where y of k is the 6-point DFT of y of n. w6 equals to e power minus j 2 pi by 6. Which one of the following is reference? See, here we know that any discrete point sequence which is x of n having a DFT of x of k, if we introduce a delay of n naught units, then we will get the for DFT of x of n minus n naught is equals to w power k n naught x of k. So if we look at the y of k, which is equals to w6 4k x of k, we will get to know that n naught is equals to 4. That means the original sequence is delayed by 4 units. We know that x of n is a periodic function. That's why origin is represented with arrow symbol at the 4. So if it is delayed by 4 units, we will get y of n as 21003, which is option B is correct. Question is, T-type master slave JK flip-flop is shown in figure along with the clock and the input waveform. The QN output of the flip-flop was 0 initially. Identify the correct waveform for the output. See, here the flip-flops we used here, they change its next state. The means its response is going to change to the positive transition of the clock. So the input waveform is given in this way and the clock is given is like this. So we have to draw the waveforms for Q0 and Q1. Q1 is the final output of the JK flip-flop which is shown in the figure. So for the Q0, if we draw the waveform, is going to be like this, because if input is 0, the output remains as it is. If input is 1, the output is going to toggle, means complement of the previous state. Here similarly for Q1, it depends upon the Q0. So the final output waveform is Q1, this one.